Okay, let's make this problem a little more complicated. What would we do if we had more than two groups? If you remember back to the parametric test, there was a set of tests that we used called t-test when we had two groups. And then when we went to three groups, we couldn't use those anymore. We had to use something called an ANOVA. Well, it's the same thing with parametrics. If we have two groups, we can use Mann-Whitney. But let's say, for example, we have this survey that we gave to boys and girls, but we also knew whether they were in 6th, 7th, or 8th grade. And we wanted to know how confident they were in regards to their math, their confidence. We have 32 questions that measure their confidence, their usefulness, whether or not it was a male domain, that meaning being whether or not math was something males were better at, and the teacher's attitude to math. Some of the comparisons we could make were, first of all, using a Mann-Whitney, is we could compare boys to girls on each of those measures. But, as I said, we also collected information about 6th, 7th, and 8th grade. So it could be that we select just the boys and then compare 6th, 7th, and 8th graders on that measure. In order to do this, we have to use something called a Kruskal-Wallis. This is the non-parametric version of an ANOVA. What this will tell us is if there is a difference between 6th, 7th, and 8th graders, what that difference is. Meaning that, let me rephrase that. It'll tell us whether or not a difference exists. What it won't tell us is where that difference is. Are 6th graders have better attitudes than 7th? Are they better than 8th? So if that occurs, just like an ANOVA does not do a good job of telling us where differences are, we have to use a post hoc. Same thing. We can use a post hoc for the non-parametrics. And what we'd end up doing is comparing 6th graders to 7th graders, 7th graders to 8th graders, and 6th graders to 8th graders on each of these measures. So whatever you see happening with parametric tests also happens with non-parametric tests. Let's say we have a situation where we have one group that's been measured twice. That sounds like a paired sample or dependent sample test. So, for example, if you give somebody a survey and you put them through some kind of treatment, then you can measure to see whether or not there is a difference between their pre-test and their post-test. We're not using a dependent sample t-test because that is for parametric data. That is for intervals data or ratio data. This is for ordinal data or small groups or non-normal groups. If we have multiple treatments, then we use something called the Wilcoxon-Wilcoxon matched pairs test. There's always a way to deal with something, so you can look at tests where you have more than one treatment. So here's an example of that. Each participant in this study is going to get a score as ranked the first time. Then they are ranked again. What we want to know is if there is a significant change in their position after a period of time or treatment. Not their position relative to one another, their position relative to themselves. For example, if I started out ranked 6, did I move up to 2? If I started out 1, did I drop down to 5? It's a pre- and post-test situation. That is done using a Wilcoxon test. So in this example, we have 6 industrial workers who were chosen for a study on the effects of rest periods on production. This is kind of like the Hawthorne studies, if you've ever read about those. Output was measured for 1 week before the new test periods were instituted, and again during the first week of the new schedule. So here's worker 1. This is without rest, their production. So he was ranked 1. This one's ranked 2, 3, 4, 5, 6. Now, with rest, we see what their rankings are. So he went from 1, he's still number 1. This one went from 6, he's still number 6. But these ones in the middle are the ones that changed. So we get something like this. We're comparing with rest to without rest, pre-test to post-test. You end up with this ranked data. And what I just want to know is how many times did with rest, was their ranking less than without rest? And that's A. How many times did their rank change from with rest to without rest? Meaning how many people went to the greater score of that. So that happened with 6 of them. And then how many of them were equal? So if we can look at this, we can determine that from the asymptotic significance, because that's less than 0.05, that for some reason having this rest period changes their ranks. Therefore, we could reject the null hypothesis, include the rest periods or make changes in productivity. However, as I said, sometimes we have to be careful about what we put in here, because sometimes it's just a matter of being a part of a study that makes the change in productivity. Here's another example. Suppose we're interested in whether situational anxiety affects test performance. We might give a test to a group of individuals under 2 types of anxiety-inducing instructions, one designed to induce low situational anxiety and the other designed to induce high situational anxiety. We want to counterbalance the order in which the anxiety-inducing situation were applied. So half would receive the low anxiety instructions first, and the other half the high anxiety instructions first. And then we'd switch them. Then we'd also give them an achievement test. So here's an example where treatment A, they get these scores, and with treatment B, they get these scores. So treatment A is a low anxiety treatment. Treatment B is a high anxiety treatment. What we want to know is, does that make a difference in terms of how they do? So this one went down, this one went down, this one stayed even, this one went down, this one went down, this one went up, this one went down, this one went down. So there were 7 people who experienced negative ranks, meaning that treatment B was less than treatment A. 1 had a positive, and then there's 1 tie. 1 person's score stayed the same. What's interesting is, despite the fact that there were 7 negative ranks, is only significant at 0.055. That means this doesn't matter. The reason why it doesn't matter is there was not enough change from their test score on A to their test score on B. There wasn't enough difference. If this had been spread out, it would have changed how far apart they were ranked. So sometimes these numbers are deceiving. You think that there would be a significant difference because there's 7 negative ranks. It really depends. Last thing we're going to look at is an article about acupuncture. In particular, this article about the acupuncture in HIV-infected individuals shows you some examples of where they've used Mann-Whitney and Wilcoxon tests. So, for example, it talks about you have to get into the article to see what these CD4 number 2s mean. Here's an example of a Wilcoxon sign rank test. Found it's not significant change for this group. That means they compared one group to itself. Here's another example where they say that this change was not significant. In this one, the difference between treatment and non-treatment groups of CD4 number 2s was not statistically significant. And that is a Mann-Whitney test. One of the things that I really question about this one, though, is they talk about the difference is not statistically significant from one group to the other, but it sounds like that they're comparing two different groups with a Wilcoxon as opposed to using this one right here is the one I wanted you to look at. While both groups increased in overall CD4 counts, but Saw's treatment group increased markedly more. When you're comparing pre and post, that still has to be a Wilcoxon test, and it sounds like what they're saying is they used a Mann-Whitney to do that. So one of the questions I asked on this slide was, were any appropriate tests used? That sounds like that's an inappropriate test. Basically, they kind of describe to you where they use Wilcoxon tests, where they use Mann-Whitney tests. As I said, Mann-Whitneys are for comparing two different groups. Wilcoxon are for comparing pre and post tests. But sometimes you got to look really closely at it to figure out what they're talking about. So that ends this slide and also ends chapter 18.